Right, guys, so the goal is the same as it has been for the circle and ellipse. That's that you can write the equation of the hyperbola and also graph it. General equation of a hyperbola. It's worthwhile to just look at the one difference between this and the ellipse. You see it? Minus. There's a minus sign. Yeah. So let's write that down, and I'll give you some terms here to go with the hyperbola. So once again, H and K are the center, just as before. A and B play a slightly different role. Instead of A being the length of the semi-major axis and B being the length of the semi-minor axis, A and B become the length. There's A. That is the half the transverse axis. The transverse axis is the axis that splits through the middle of the hyperbola. It's the direction in which it opens. So this is called the transverse axis. And the A will go underneath the Y, representing the transverse axis if it's opening up and down. Okay? And then also these terms will switch order. You'll have the Y value first if it's opening up and down. This right here, different color, is B, or this is B, and this is called the conjugate axis. We have vertices. Here is a vertex, one of the vertices. Yes. What's that? Backside. We're on the backside. Yeah, I hope punched it as if we're doing the parabolas first. So conjugate axis, transverse axis, vertex 1, vertex 2. The definition, the definition is kind of like it was for an ellipse. Remember an ellipse, that the sum of the distances from a focus to a point on the ellipse to the other focus, the sum was always constant. Here, it's the difference that's always constant. So we have somewhere over here we have a focus. We'll call that focus 2. And somewhere over here we have focus 1. So if you draw a segment from focus 1 to a point on one of the halves of the hyperbola, and then draw a line segment over to focus 2, the difference between these two will remain the same at all times. Hyperbole means to exaggerate. Hyperbola is to exceed or go out from. The key to graphing these is this hyperbola box. You probably did some graphing of it with the hyperbola box last year. I don't know, did you look at the terms transverse and conjugate axis? Okay. So we're going to find the hyperbola equation. We're given that the x-intercepts are at plus or minus 4. That tells me if the x-intercepts are plus or minus 4 that it opens left and right. Let's draw a picture. One thing with this here, we're going to need a lot of room up above it. I don't know if you can, sorry, I should have warned you before, but 1, 2, 3, 4, 1, 2, 3, 4. Make it kind of small. I'll show you why in just a minute here. Okay, so we have x-intercepts are plus or minus 4. Not allergic to hyperbolas, are you? Oh no, that's okay. I'm allergic to pre-calculus students. So we have plus or minus 4 here, and then we have an asymptote of y equals 5x over 2. The asymptotes are, this is one asymptote here, and here's the other asymptote here. The asymptote is the diagonal of that hyperbola box. And so by giving you the equation of the asymptote, you can use that to figure out the other dimension of the hyperbola box. Now we know the center is 0. We're going to assume the center is 0. The box goes out to 4 and then out to -4. The question is, how far up does it go? Well, if I have an equation, y equals 5x over 2, starting at 0, I'm going up 1, 2, 3, 4, 5, and over 2. And I'm going to go up another 1, 2, 3, 4, 5, and over 2. And that's going to be the graph of my asymptote. And so what that tells me is I have to go up 5 and over 2 twice to get all the way over to the right edge of my box. You see that? Up 5 and over 2 just one time won't get me there. So that tells me what the height of this box is going to be. And we won't draw the bottom half, we'll run out of room there. But that asymptote equation gives me the height of the box. It's going to go up 10 units from the center. And so that gives me an idea of how wide this hyperbola is. Once you've drawn in those asymptotes, we know that the vertex is right here. It's going to go like this and like this on the other side. And then here we have one going like this and like this. So the key to graphing these is getting that hyperbola box. Then you know how skinny or wide the two halves of that hyperbola are. So now it's just a matter of plugging in H, K, A, and B. We see that it opens left and right. In this case, A is 4 and B is 10, and H and K are 0. So I have x minus 0 squared minus y minus 0 squared equals 1 over something over something. And so the x is over 4 squared and the y is over 10 squared. So it's about which way it opens. You got to make sure that underneath like if it opens left and right, that it's underneath the x that you have these values. The x term is first if it opens left and right. It's the positive value. And then the conjugate axis is the negative value. So if I clean this up, it's x squared over 16 minus y squared over 100 equals 1. That's my equation. Any questions on that? That may be new, getting the box from the asymptote. That's how we go about doing that. This one, we have a vertex at 0, -2. That's one of the two vertices. So that tells me this. I go to graph this. We have a vertex at 0, -2. That tells me that it opens up and down. If I have a vertex at 0, -2, I also have a vertex at 0, 2. And I have a box that has a couple of sides at least looking like that. Now it says it passes through the point 6 root 2, comma 6. Erase this for a minute. So 6 root 2, comma 6. 2, 3, 4, 5, 6. 6 root 2 is going to be about 6 times 1.3 is 6, plus 1.8 is 7.8. So 2, 3, 4, 5, 6, 7, 8. And then up 1, 2, 3, 4, 5, and 6. So it goes through this point at 6 root 2 over and 6 up. So it's going like this. So when I say a vertex is at 0, -2, that tells me another vertex is at 0, 2. They're very symmetric. Okay? placing one vertex on the y-axis puts the other one there as well. Passing through the point 6 root 2 comma 6, my best estimate is I'm about 8 out. I'm using 1.3 or so for root 2. 6 times 1.3 is about 8. And then 6 up. So it's passing through this point. So, you know, I don't really need my hyperbola box. I'm just getting a rough sketch of this so that I can go and find the equation. That tells me that the y term is going to go first this time. The center, it looks like, is still 0, 0. And so here's what I have. I have y minus 0 squared over something minus x minus 0 squared over something equals 1. So I've established my center must be 0 again, and I've also established that the y term is positive because it's opening up and down. Now underneath the y term, I have a distance of 2. So 2 squared underneath the y term. Now the question is, how do I figure out what b squared is? How am I going to figure out what b squared is? Well, this goes back to what you've done before in Algebra 1 with the linear equations. As a matter of fact, the letter you're trying to find is even the same one. When you're given an equation of a line, say you're asked to find an equation of a line parallel or perpendicular to a given line, what you would do is you would figure out the slope based on the definition of parallel. It's either the same slope as the line given or opposite reciprocal. Then you are also given a specific point x and y that it passed through. So you had m, x, and y. You remember that? And you are left to find b, and then you write the equation. This is the same principle here. We have an x and a y. Here it is, right here and here. Let's do that in red. So maybe label that x and y. That value, 6 root 2, can go in right here. That value 6 can go in here, and you're left with only one variable to solve for. It's kind of messy, but we can handle it at this stage, right? So our goal is to get this equation in general form. The ultimate goal would be to get the mathematical model so you could give me an x and I can give you a particular y on the curve. But we're just going to get the general equation here. So it looks like this. I have y squared, and I'm going to replace y with 6. So it's 6 squared over 2 squared. And then, what's that? I'm plugging 6 in for y and 6 root 2 in for x. So then I have 6 root 2 squared over b squared equals 1. So 36 over 4 would be 9. And then 6 root 2 squared is 36 times 2, which is 72 over b squared equals 1. I'm just going to keep going down the side here with the algebra. Subtract 9 from each side. So it's minus 72 over b squared equals negative 8 over 1. I'm subtracting 9 from each side. And then I have a proportion again. I can cross multiply and solve. So it's 8b squared equals 72. I'm just dropping the negative sign because there's 1 on each side. B squared equals 9. And the positive square root of b is just 3. And that's the only one I really care about. Just whether it's positive or negative, I'm going to square it. So ultimately, I could have stopped right here at b squared equals 9. That's all I needed. So that means my equation is this. I'm going to erase this bottom half here. I have y squared over 4 minus x squared over 9 equals 1. I just found b squared. I replaced b squared and put x and y back in the equation, just like you do with linear equations after you find b, the y-intercept. I have the same principle there. And then I could find any other point along this hyperbola. You could give me an x value of any x value, and I can give you a y value to go with it. As a matter of fact, I'd give you 2 of them. This is not a function, right? So any x value you give me here, there's a y value up here and also down in this bottom half. All right. Any questions on what I did here? I went through all the algebra because you'll be doing it again. Maybe the first time you might need to look at my notes, and after that, it'll be fine. All right, find the equation of a hyperbola with center -4, 1. Oh boy, now this time we're centered elsewhere. So let's see if we can draw a picture of this. Vertex at -7, 1, and passing through the point, that's the point -4 plus 3 root 7. That's the exact value of a point in radical form, comma 13. So -4, 1 is the center. And -7, 1 is the vertex, one of the vertices. So based on the fact that this is the center and this is one of the vertices, can you tell me one other vertex? And it's 1, 2, 3 over, so 1, 2, 3, -1, 1 is another one. Can you tell me which way it opens? Left, right, yeah. Because it's got to be in line with where the vertices are located. Can you tell me approximately what the x value of -4 plus 3 root 7 is? You might need your calculator to do that. So I would need one. So -4 plus 3 root 7, approximately what is the value of that? 3.9. Okay, so about 4. Okay, so I got to come out a little bit farther here. And way up at 13, so way up here, we have that point. So we'll go like this. Okay, so there's just a rough sketch of what this thing looks like. Just a rough sketch. Opens left, right. It's got vertices at -7, 1, and also at -1, 1. That means that A is 3. So I have x minus -4 squared over a squared, which is 3 squared, minus x minus 1 squared over b squared, y minus 1. That's all right. Y minus 1 squared over b squared equals 1. So to find my b squared, I'm going to need to plug in that point. That point's kind of ugly, but it'll come out okay. -4 plus 3 root 7, comma 13. So we're going to plug this -4 plus 3 root 7 in right here. And it'll be okay. Watch. This is actually x plus 4 squared, right? So I'm going to plug in -4 plus 3 root 7 plus 4, and then square that number, and that will be over 9. Minus y minus 1 squared. I'm going to replace y. Let's replace it with 13. So 13 minus 1 squared over b squared equals 1. And what does this value, this whole term, become? -4 and +4 will cancel out, right? 3 squared is 9. 9 times 7 is 63. 63 divided by 9 is 7, so it comes out okay. 7 minus 13 minus 1 is 12. 12 squared is 144. Over b squared equals 1. Subtract the 7 over, get rid of the negative signs. You have 144 over b squared equals 6 over 1. We cross multiply, divide. 6 goes into 144. 24 times, so b squared equals 24. So I just need to take this thing and rewrite it. It becomes x plus 4 squared over 9 minus y minus 1 squared over 24 equals 1. And that's the equation of my hyperbola. So you don't need to take the square root and then re-square it. B squared equals 24. So that's finding the equation of the hyperbola with lots of different given information. Any questions on that? All right, let's go the other direction then. Move this up here, this up here. Graphing these. If I'm given x squared over 9 minus y minus 2 squared over 4 equals 1, what's the center? 0, 2. That's right. So place dot here at 0, 2. Which way is it opening? Can you tell? Left, right. So my hyperbola box will go, there's a squared equals 9, so a equals 3, b squared equals 4, b equals 2. It will go 3 in each direction horizontally, and 2 in each direction vertically. Draw the box. And it doesn't hurt to draw in the asymptotes, then at least you know how wide it is. And then just quickly sketch it. It's going to approach those asymptotes like this. And that's it. Find the center, figure out your A and B, count that amount out from the center in each direction, draw your hyperbola box, draw the asymptotes, and draw the branches of your hyperbola. So that's the process. Some of you guys are drawing the next graph. Sorry, I didn't put the graphs on there. Go ahead and sketch a little XY grid. Anybody have any more questions on this? I'm gonna reuse this grid over and over again. So. All right, the next one's not quite ready to graph yet. First thing I'm gonna do is move the 5 over. So I have 20y squared minus 80x squared equals 5. And then I need to get a 1 on the right-hand side. So I'm going to divide through by 5. So when I divide through by 5, this becomes 20 over 5, or 4y squared, minus 20x squared equals 1. Now, as you're looking at that, you're going, no, that doesn't quite look like the right form. We usually just have a number on the bottom, right? A number on the bottom. So we can force that. We can make that happen by doing the following here. This is the same as y squared over 1/4. Think about it for a minute. If I wanted to take y squared and divide it by a fraction 1/4, that's equivalent to multiplying it. by the reciprocal 4/1. So if you have coefficients in front of these, it becomes the reciprocal of it below. And then this is, so now it's in the right form. A squared equals 1/4 means A equals square root of 1/4, 1/2. B squared equals 1/20 means B equals, that'd be taking half of it. It'd be 1 over 2 root 5. Yeah, square root of 20 is equal square root of 4 times root 5, which is 2 root 5. Yes. Oh, 16. Okay, that would be the correct value. Thanks. That'll make life easier. 16x squared. Sorry about that. So this is 1/16. So b squared equals 1/16. So b equals 1/4. That's a little better. Yeah, 80 divided by 5 is my mistake right here. 80 divided by 5 is 16. So I have 1/16 on the bottom. And the square roots of each of those are 1/2 and 1/4 respectively. So my scale isn't the best one here. You really want your own scale, one that is going by fractions. So I could maybe go by 1/4 or 1/16. Let's see, 1/4 would probably be good. So go by 1/4. We've got a center at 0, 0. If this is 1/4, 2/4, 2/4, 3/4, 4/4, this will be 1. Let's erase this. 2/4 is the same as 1/2. And so if you scale it by quarters, so centered at 0, 0, I'm going to go in the A direction here. A is underneath my Y. It's going to open vertically, and A is 1/2 in each direction. So I have a dot here and a dot at -1/2. And then the conjugate axis is 1/4, so going this direction, this direction. Draw my hyperbola box. So 1/4 left or right, 1/2 up and down. Draw in my asymptotes. And then it's going to open upwards. The purpose of that one is to demonstrate that even if you have a coefficient in front of the x squared or y squared, you can move it down and just write its reciprocal underneath. Any questions on that? Start drawing the next graph. Right. Let's bring the numbers back in. This one is going to open up or down? Up, yeah. So we've got a 3, -1 is our center. A is equal to 5, B is equal to 7. So if I'm at 3, -1, and go 1, 2, 3, 4, 5 to the right. Oh, no, that's going to be up and down. Again. So 5 up from there. 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5 down because I am underneath y. And then I'm going to go 7 in each direction on x. I can't zoom out anymore here. It'll change my scale to go by 2s. I don't want that. So we'll estimate as best we can. 1, 2, 5, 6, 7 is about out here. 1, 2, 3, 4, 5, 6, 7. And then we'll draw our hyperbola box. Draw our asymptotes through here. And then it opens upward. And all that is a very quick sketch based on the dimensions of the hyperbola box and the center. Center's located. All right, and then ultimately what we want to be able to do is take something that's in this is called the general form of a quadratic. And right off the bat, you should be able to tell that it is a hyperbola. You see the x squared, y squared terms with a minus in between. We'll talk a little bit about that when we summarize all this. But you can tell even in general conic section form here, this is almost in that form, what the shape is. Any questions on this one? I think I'll do a little bit of algebra before I look at the scale here. But we've got to complete the square with this one. So I'm going to group x terms together. Here's 2x squared. I'm going to bring the 12x over. Minus 7y squared plus 14y. I'm going to leave the constant over on the right-hand side. All right, now before I can complete the square and work this into the general form of a hyperbola, standard form of a hyperbola, there's a couple things I need to do. One is I got to factor out the coefficient of the x squared and the y squared. The other thing I have to do is when I factor out the coefficient of y squared, I'm going to be factoring out, I got to be a little bit careful on how I do that. When I factor it out, I will have this minus sign that will need to be distributed to whatever I add in to complete the square. So a couple things to be aware of. So before you can complete the square, you need a coefficient of 1 in front of the x squared and y squared. Do you remember that? Does that please ring a bell? You need to have a 1 in front. So I'm going to factor out a 2 here. I'm left with x squared plus 6x plus something. That one's not a problem. It's kind of like the ellipse. Now this one, I'm going to go ahead and have a minus sign here. And I'm going to pull out my 7. And I have y squared. Negative 7 times what will give me 14y. Yeah, and then a plus sign here. Equals 17 plus something plus something. So now I'm ready to complete the square after factoring out that coefficient. So here I have 2 x squared plus 6x plus 9 minus 7 y squared minus 2y plus 1 equals 17 plus, now I'm not adding 9 and 1, I'm actually adding 2 times 9, or 18, and negative 7 times 1 is negative 7. So you might want to draw a little diagram showing what you're actually adding in there. So the right-hand side, I think I have 28. Left-hand side, I have 2, and then times x plus 3 squared minus 7 y minus 1 squared. And all of that equals 28. Any questions on that? Completing the square step. Factor out the coefficient of the x squared, y squared. And when you complete the square, don't forget that you're actually adding whatever you've pulled out times that number to each side. And when I divide by 28 here to get 1, this will be 2x plus 3 squared over 28 minus 7y minus 1 squared over 28. Because one this time, when I simplify, I end up with just a number on the bottom. So it's x plus 3 squared over 14 minus y minus 1 squared over 4 equals 1. All right. Did I scroll up enough? Can you see it? All right. Any questions on the algebra there before we graph it? Okay. So in this case, a is equal to the square root of 14, which is about equal to a little less than 4, right? So 3.8-ish. What's that? 3.7? Okay. So the center is at negative 3, 1. So 3 left and 1 up is my center. I'm going to go about 1, 2, 3, 4, about 4 units in each direction parallel to the x. I'm going to go b is equal to square root of 4, which is 2. I'm going to go 2 up and 2 down. Draw my hyperbola box. And then draw asymptotes through here. And then it's going to open in the x direction. So a lot to pay attention to here. Maybe use a pencil if you're doing this. You got to pay attention to where is the minus sign, and which way does it open?